All right, hello and welcome to the helper video for worksheet 5.5. If you're struggling with any of the problems, make sure you watch these. We are going to do problem number 1, problem number 7, problem number 11, problem number 15 and number 16, problem number 18, problem number 20, 21, and 25. You can skip right on to the one that you guys are having problems with. Let's start with number 1. We need to name the smallest and largest angles of the triangle. So we need to do the smallest and the largest. By the way, this floating one doesn't really matter down there. I don't know why I printed out there, but it did. So first thing we do is we look at our numbers that we're given for our lengths of our sides. To find the smallest angle, we look for the smallest side. Smallest side is 5, so we look the opposite angle of that side is our smallest angle. So angle N is our smallest angle. To do the largest side, we look for our largest angle. We'll look at our largest side, go across from that, the opposite of it. That's our largest angle is angle M. All right, now we're going to do number 7 where it says name the shortest and longest sides. So we have our shortest side we need to find, and we need our longest side. The problem we have in this triangle is we only are given 2 angles. So we need to find that third angle. Remember that the interior angles of a triangle add up to 180. So the measure of angle, this doesn't have a name, so let's call it A. ABC, measure of angle A plus measure of angle B plus measure of angle C equals 180. So all we have to do is take the 2 that we have, add those together. Then we're going to take that 113, which is what those 2 add up to get, and get what's left, which is 67 degrees. That means my angle A is 67 degrees. Now again, just like we did with the sides, we can look at to find our shortest side, we're going to look for our smallest angle. So our smallest angle is 42 degrees. So across from that, we're going to name this side here. Now we can either call that AC or CA. I'm going to call it AC and make sure we put our segment symbol above it. Next, we're going to go and we're going to do our largest side, our longest side. Well, then we look for our largest angle, which is our 71. Go across from that. And across from that is going to be our longest side, which is either going to be AB or BA, whichever one would work. All right, now we're going to go on to number 11, where it says to describe the possible side lengths for the third side of this triangle. Well, remember, we know that the 2 sides have to always be bigger than the third side. And so what we need to do is we need to look, well, what if 12 is our biggest side? Well, then the third side, 6 plus that number, so 6 plus our mystery side length has to be bigger than 12. Really, all we have to do is we know that we're going to subtract 6 here to get x alone, so x has to be greater than 6. But what if x, our third side, isn't our middle side? What if 12 isn't our biggest side and our x is the biggest side? Well, then we know that 6 plus 12 has to be bigger than our third side. So what's 6 plus 12? Well, it's 18 is bigger than x. And now we can put that all together. The smallest number we can be, sorry about that interruption, the smallest number can be 6, so a little bit bigger than 6 we can get to. We can't actually get to 6. Biggest number is 18. So we know that 6 has to be less than x, which has to be less than 18. On the future problems for this one, you really can just use the skeleton. We know that it's always going to be in between those 2 numbers. To get this first one, do the biggest number minus the smallest number. And then for the second part, which was 6, the second part we'll do the big number plus the small number, which is 18. So you can do it a lot quicker, but I wanted to explain why it works the way it did first. All right, now what if I don't just ask for the actual side length that it could be on there for the third side, but I give you an equation to go with it. Here's my equation. It's 2x minus 2. And our 2 side lengths that we're given are 5 and 7. Well, let's treat this third side just like we treated it last problem. Let's look at our 2 side lengths, the possibilities. The first thing is, Well, what if 7 is the biggest side? Then we'll just do 7 minus 5, which is 2. The second option is what if 7 isn't our largest side? So we're going to add them together, which is 12. Now our third step, we're going to put these together and we're going to solve for x. So our smallest number is 12 is less than something. Sorry, 2 is less than something is less than 12. Now we're going to take our equation and plop it right in. 2x minus 2. Now we need to solve for x to get by itself. So I need to add 2 to get rid of that, minus 2. But whatever I do to one piece, I have to do to all three of my parts. So 4 is less than 2x, which is less than 14. Then we're going to go and we're going to divide by 2 to get 2 by itself. So we get 2 is less than x is less than 7. And there's my actual answer. And what that tells us, the x values that we can plug in for 2x minus 2 to make it actually work as a triangle would be between 2 and 7. So let's do that again with number 16 so you can kind of see the steps again. So again, here's our equation. Here are our two side lengths that we have. Well, what if 12 is the biggest side? Well, then we do 12 minus 8, which get us 4. Well, what if 12 is the not the biggest side, our medium side? Then we would do 12 plus 8, and our biggest side has to be less than 20. And then our third step, we put them together. So we'd have 4 is less than 2x plus 2, which is less than 20. Now we just solve. Subtract 2 from each piece. 2 is less than 2x, which is less than 18. Then we divide by 2. And we get 1 is less than x, which is less than 9. So that means that the x values that we can plug into that equation, or that expression 2x plus 2, have to be between 1 and 9. All right, number 18, it's a bit wordy, so this might be a good one to use the cubics for. So let's circle. So first let's read it. We're going to sketch and label a triangle for this. So side lengths are 14, 17, and 19, which the longest, that might be a good one to box, is at the bottom. Now that bottom is a key word there. I know it is. It might not be good vocabulary, but it's definitely a key word. Our angle measures are 45, 60, and 75, with the smallest being at the right. Well, now I know what I need to do is just sketch a triangle. So since it doesn't say anything about something being on top, we have the longest on the bottom. I'm going to try to make my longest side on the bottom. Then it doesn't really matter because it's just a sketch. So our longest side at the bottom, well, our longest number, we have 14, 17, and 19. Our biggest number is 19, which means that goes on the bottom. Now we look at our angles. We have 45, 60, and 75. The smallest angle has to be on the right side. Well, 45, 60, and 75, the smallest number is 45. The right side is on the right. Now we have to go figure out some other parts, the rest of our places that we're going to put them. Remember from the previous problems, across from my biggest side, that's where we're going to put our biggest angle. So our biggest angle is 75 degrees, so that goes there. Across from my smallest side, that's where I'm going to put my smallest side, my smallest angle. Across from that, I'm going to put my smallest side. Now we just have to put what's left over. Well, we have 14, 19 already written, so 17 has to be there. And we have 45 and 75 already used, so 60 has to be there. Also, across from the 60 is our medium side and our medium angle. So it worked out perfectly. All right, for 20, 21, and 25, is it possible to construct a triangle with the given side lengths? If not, explain why. So remember, our two side lengths always have to be bigger than the third, and it has to work for all combinations. But really, we just have to look at the two smaller ones added together. So 20, 3, and 4 are two small numbers. Is that bigger than 5? We need to figure that out. Well, what's 3 plus 5? 3 plus 5 is 8. And 8 is definitely bigger than 5. So can we make a triangle? Yes, we could make a triangle. Do the same thing for 21. Two small sides, 1 and 4. 1 plus 4, is that bigger than 6? Well, 1 plus 4 is 5. Here's 6. 5 is definitely less than 6, so this is not going to work. We cannot make a triangle because our two side lengths, our two sides added together, aren't larger than the third side. Now I'm only going to give this explanation once, and whenever it happens again, I'm just going to refer back to that explanation because I know you guys probably don't like writing that much either. Okay, now let's look at 25. 25 is a little bit different because we didn't put them in order from smallest to largest. 754 and 4. Remember, we're not looking at the first two numbers, we're looking at the two smaller numbers. Is 4 plus 7 greater than 54? Well, hopefully you can see it without even doing the math. 4 plus 7 is 11. That is way smaller than 54. So can we make a triangle? No. And there's our same explanation over there. All right, hopefully the video helped. If you need to go back and rewatch any parts because I went too fast, go ahead and feel free. Otherwise, if you still have questions, make sure you ask your teacher. Make sure you do all the rest of the other problems to make sure you actually fully understand the material.